This video will likely help you with a lab that you could potentially do for this class. And if you have a spirometry lab, this will be something that you'll want to definitely review. Even if you don't, we're going to talk about it in class. And so pulmonary volumes and capacities, we have this one outcome. Okay, so here we've got a figure that shows 8 different volumes and capacities. On the x-axis is time, on the y-axis is volume. Okay, and don't worry about the units here. It doesn't really matter what they are. But what you need to know are a couple things. One, as we go up the x-axis here, so this is inhalation as we go up, exhalation as we go down. Okay, right here we've got this bottom line, this bottom horizontal line. That line is the most, or is how much you hit that line when you've breathed out as much air as you possibly can. But notice that line is not at 0. You're never able to breathe everything out. Okay, and we'll get into that in a little bit. And then you've got these other 2 horizontal lines here. And that's where you're normally at when you breathe in and out normally. And then obviously up at the very top, that's when you filled your lungs up maximally. Okay, so from here, we're going to talk about 4 volumes, and then we're going to talk about how these other capacities are a sum of those 4 volumes. So to start off, inspiratory reserve volume, but like I just said, a volume is something we measure. A capacity is a sum of at least 2 volumes. So inspiratory reserve volume is the maximum amount of air that you can take into your lungs after normal inspiration. So in other words, as you're sitting here, I would encourage you to do this with this volume and then all the others that we talk about. Take a normal breath of air in. Now you get to the point where you're ready to breathe out. Well, then just fill your lungs all the way up. That's inspiratory reserve volume. This is something that can be directly measured. Next, we've got tidal volume. Okay, tidal volume is just how much air you're moving in and out of your lungs during normal breathing. Okay, tidal volume can increase, like when you exercise, your tidal volume increases. Okay, so like I said there, and again, this is something that can be directly measured. Okay, it's that yellow line on the figure there. Next, we got expiratory reserve volume. So it's the green section of this figure. It's where the arrow's at. So it's very similar to inspiratory reserve volume. So this would be take a normal breath of air out. And as you're getting ready to breathe in, instead of breathing in, breathe out as much air as you possibly can. Okay. We actually use this to diagnose whether or not someone has some sort of lung disease. We can also directly measure this. Okay. So these first 3 volumes we can directly measure. Finally, we've got residual volume. Residual volume is shown at the bottom of this figure. It's in purple, and you also see the arrow there. So with expiratory reserve volume, we talked about how we breathed out all the air that we possibly can. Well, residual volume is after you've breathed out as much as you possibly can, what's left in your lungs. The reason you can't get all of the air out of your lungs is because in order to get air out, especially when you're at low lung volumes, you have to generate a lot of pressure. This pressure causes airways to collapse. And as a result, air gets trapped. What does this mean? We can't directly measure residual volume, but we can use some fancy equipment to give us a pretty good idea. We can estimate it and calculate it using Boyle's law. So those are 4 volumes. We've now got 4 capacities left. Each of the capacities is the sum of at least 2 of the volumes we've just reviewed. So inspiratory capacity. So this is the maximum amount of air you can inhale when it's time to inhale. Okay, or in other words, I've just finished breathing air out. How much air could I actually get into my lungs if I wanted to fill them all the way up? This is something that increases during exercise because you take more breath in, but you also get rid of more air when you breathe out during exercise. We can directly measure this. Okay, this is the sum of tidal volume and inspiratory reserve volume. Then we've got functional residual capacity. So this is the amount of air that's in your lungs after you've finished breathing out normally. Okay, because it involves residual volume, we're unable to directly measure. The mathematical formula would be expiratory reserve volume plus residual volume. One other thing that's really important to know about functional residual capacity is that's the point where the recoil of the lungs is equal to the expansion of the ribs. That's why we breathe to that point. If you just think about it for a minute, you don't feel a lot of pressure at the end of a normal breath out. Then we've got vital capacity. So vital capacity is just what's the maximum amount of air we can get in and out of our lungs. Normally to do this, we fill our lungs all the way up and then we blast air out until no more air comes out. Vital capacity is used to diagnose lung disease as well. Okay. For those of you that have had asthma or have been tested for asthma, one of the things that they almost certainly measured was your vital capacity. Okay. We can directly measure this, and it's in IRV plus tidal volume plus ERV. And that just leaves total lung capacity, which includes all four of the volumes. It's exactly what it says it is. How much air is in your lungs when you fill them up all the way? But because it involves residual volume, we're unable to directly measure it. Okay, so it does involve all four of those volumes. What you can also do is you can just do vital capacity plus residual volume. So I hope that you can identify all 8 lung volumes and capacities and describe each of those volumes and capacities.